Hello, welcome to today's Leak Code problem solving session. Today's problem is 1509. Minimum difference between largest and smallest value in three moves. Okay, so the question goes like this. You are given an integer array nums. In one move, you can choose one element of nums and you can change it to any value. Return the minimum difference between the largest and smallest value of nums after performing at least three moves. Okay, so huh. Says you can choose one element of nums and change it to any value. Return the minimum difference between the largest and smallest value of nums. So here it's 5324, and that changing. Uh, so since we can do at least at max three moves, they are changing two to three and five also. Four also to three and five also to three. Okay. So yeah, if size of nums is less than equal to 3, then I guess the answer would be 0. I mean 7 uh, seems to be an arbitrarily randomly chosen number. So what's the like okay, and we can have until 10 power 5 uh, numbers here. Okay. Mm, Uh, trying to figure out the basically like the crux of the problem here. Let's go through example 2 again. Since we can change three numbers, they are changing all of them to basically the second lowest number. Yeah, I mean, they could change 0 to 1 and another number to also 1, but then still we would have a very large difference. So, how do we choose these three moves? That's like the interesting question here. Hmm. It doesn't seem like it requires a high data structures algorithm uh, approach, but So I'm kind of like trying to think of my approaches here. So like if nums are three or less numbers, um, the answer is zero, right? Because we can always bring it to even four, you can bring it to zero. I guess when uh, it starts becoming complicated when you have more than four numbers. So when you have five, here let's say you can change three of them. And I guess one way to change those numbers is that bring put them all, you know, make them all one of the take the smallest difference, which is one and zero, and bring all the max leave mostly varied numbers and bring them to this one or zero. Try to like think a little bit deeper than that. Yeah, I guess like find the not. I guess this won't always work. It will only work if we have five. So basically, we find the third biggest difference, or like fourth biggest difference, and yeah, there's not much if we can do other than that, right? If so, I mean, for us to calculate all the differences, it would take n square. That's too much. I guess that's the problem here. Try to find the third or like fourth biggest difference. Because if you have like more than four numbers, you can only change three of them. And what are you going to change them to? Even if you change them to somewhere between like, let's say you have like 1, 5, 3, 10, 4. So that 3 and 1 will be like the biggest difference. It's the same as 2 and 5. So you can change the other three to somewhere between 1 and 3, which is 2, and still 2 will be like the biggest difference. But I guess once we sort things out, if nums is sorted, we can use the first three digits and the last three digits to give us to basically find all combinations of the largest. So that would be like a two choose six problem, or six choose two. So I think it will like I'm not really good with like combinations. uh, 2 choose 6, or like 6 choose 2. Yeah, I guess that would like only create 10, or like, sorry, yeah, that's 3 and 3. Not sure why I'm even like taking 3 and 3, but it's kind of what my gut says. So 3 choose 2, 6 choose 2. So we'd have like 15 of them, and we basically take the fourth difference out of them. But I don't want any duplicates in this if we have like only 5 numbers, 6 numbers. So start sort, and basically let's say I and j is equal to 0, and max of nums minus, sorry, length of nums minus 1. So let's make an array, and while length of array less than 6 and I less than, I guess equals to is also fine. Array dot append uh, nums I, array dot append nums j. Right, I minus 1 j, oh, I plus 1 j minus 1, and yeah, we have like the top 3 and like bottom 3 elements, and I guess we could like call and make another array defs, and for I in range uh, the 6. No, let's not do 6, let's do length of array because size of array matters again. And since I don't want any like doubles for j in array I plus 1 and to length of array, uh, defs dot append absolute value of array I minus array j. Okay, it's not 15, but like I'm guess it will be somewhere close to that. It will be n into n plus 1 minus 2, something like that. So one modification, I mean, I can sort the diffs, and I want to sort in reverse because like I'm going to pop out the first 3 values, and it's easier to sort pop from the end rather than start. It's more efficient. So while I don't think it matters in Python, but because I guess in Python it would just remove and like change the pointer internally anyway. But yeah, while diffs and uh, copy zero, let's say, and we don't want to pop everything. We want to like make sure that there is at least two. Oh no, let's pop everything. There is nothing. Pop less than four. Defs dot pop return zero f def, right? Uh, def is none, or if not def, else def minus one. I don't know if this will work. Seems like a very weird problem for lead code anyway. List is not callable. Hmm? Oh wow, def is not. Oh my god. Hmm. Output is zero expected as well. Why though? Oh, oh plus one. No, it's wrong for everything. Interesting. Yeah, one more issue is when I is equal to j, it's gonna return both, add both to the array, and we don't want that. So, still, it's not sure if this is gonna work anyway, but at least for these cases, I think it should. Okay. Okay, the issue is once I change a number, all the diffs related to that number will also change. So, but here we're not doing that. We're changing the diffs, but not all the values, all the other diffs related to that specific diff. So I don't think this is gonna work. But I think the basic idea is valid, which is we are kind of looking at the first few differences only. I guess anyway, the issue is that like we are either looking at we're generally looking at the biggest difference, which is easily the largest number minus the smallest number. But I guess the question should be like, if we are going to change one of these numbers, what number do we change it to? We can't change it to like second biggest because uh, when we change the second biggest, I guess we could like just see by if we remove one of them. Okay, we can remove them based on how the second biggest difference uh, is modified, right? So we're gonna remove all this code. I guess it's safe to say that if length of norms less than equal to 4, or like less than 5, return 0. So this is 0, this is 0. So we're gonna sort them, let's say. Uh, Sort this. This becomes 1, 0, 1, 5, 10, and 14. Okay, I think we need to remove this in such a way that, okay, if we remove, let's say, 0, then the biggest difference is gonna be uh, 13. If we remove 14, the biggest difference is 10. I mean, for this problem, this hypothesis makes sense, but I guess I'll make up some other test cases to check if this works. So, while, uh, okay, while nums, yeah, we have ing already here. I'm gonna remove this. So, if nums I, so absolute values. Hmm. K minus 1 greater than, so that would be like if and I less than j, because when I and j matches, it's kind of like we can just return 0 anyway. So let's say we have 0 and 14. If we have to check whether this difference is the biggest or 1 to 14. So let's say we kind of want 14 to go, and this difference is lower, less than absolute value of nums I plus 1 going to absolute if I'm just flipping these, right? J. So I don't want to write like too much unnecessary code. It's not that worried about the math or anything. than j minus nums I plus 1. I decrease j here, else I add I. Then nums I, okay, let's do j minus nums I. We could do this only 3 times, not more than 3. So count value 0 less than equal to 3. This is more for like readability. Interesting. We are sorting them, right? Yeah. Print ing. Oh, both are 1? No, this should be less than 3, I guess then. Oops. Okay. Let's write another case like, just like random, but not so random. I mean, I can go as big as I want here. This doesn't work, I'll write a more believable test case. This seems to be working. Yeah, I don't. Uh, the solution is too weird for me to like be like, oh, this is working. Yeah, it's like a weird problem. I don't know if it's gonna actually work. Okay, it didn't work. Interesting. So expected is 17, output is 33. Let's sort these numbers out here for our case. I'll just print sorted. So remove this. So we have 9, expected is 17. So here's the difference between these three are 17 and these two are 17. So here let's say let's print nums I to j plus 1. Interesting, we are at 48, 48 and 81. But we would have been better if it was 48, 31, 48, 48. That is so weird. So like when we had assume like, yeah, let's actually do another thing. Since we have the original here, it should print right under it. So we can see the progression of what we are removing here. So we have uh, So the difference between 9 and 92 is what, like 83? Yeah, but like that. The difference between 9 and 81 is 72, and 3 and 31 is like 60s, 61. So we removed 9. 31 and 81 is 50. 92 and 48 is like 40, no, ooh, 39. So it'd be like 46 minus, sorry, damn, 84 minus 40, so that's 44, right? 44, and this is 50. Wait, what? So why is it um, 31? Oh yeah, this is difference is 50, and this is, yeah. So removing one at a time with the biggest difference is not the, it doesn't give us the optimal solution. Okay, that's a new revelation we have. Hmm. So what if we backtrack? Uh, it's not, since it's only three, it should not take a lot. Yeah, I'm gonna do a backtrack. So, uh, def backtrack I and j, and we will also use depth 0. It's also like make them all names. So equal 0, j is equal to length of j plus 1, no, length of nums. We kind of don't need this then. It would give us a little better optimization. I don't know. Let's move. And if I is j, then 0. If depth is, oops, oh, my computer's like slow right now. If depth is 3, return nums j minus nums I, I. Now you return backtrack. Hello. Yeah, still recording. I plus 1 j, I plus 1 comma j, depth plus 1. Let's do like a min, right? Comma backtrack j plus 1. No, uh, I j minus 1 and depth 1 plus 1. Hopefully this works. Index out of range. Okay, what if I do this? I mean, how's that even possible? It's not even possible. 7, 17, it's like 0 for everything. Oh my god, I mean, creator. Index out of range. So stupid. It still doesn't work. Wow, how is G? Oh, because we didn't sort. Oh my god. I removed the sorting code. Mm, seems to be working. Mm, yeah, I really suck at coding, but I get the problem done. Like I get, get things solved. That's all I can say. But I really suck at coding. So yeah, peace.